Okay, so today we're continuing our journey through the index laws. So let me remind you, so far we have only 2 index laws. You might know a few more. You don't need to write this down. But so far, whenever we've seen 2 numbers with the same base, if we multiply them, we can apply a law. If we divide them, we can apply a different law. So just call it out. What would the first one be if I simplify this using the index law? Right. So if you have the same base and you're multiplying the 2 numbers, you're going to add the indices together. What about the other one? If I have 2 numbers with the same base, which are in index form, but this time I divide them, what should I do, Shannon? Great. I'm going to minus or subtract the indices. You've had plenty of practice with this. Today we're going to add one more. Today we're going to multiply the indices. It's going to become easy to confuse them. So I'll try to make this clear over the next couple of weeks. All right. So I would suggest you get all of this down in your books. So I'll just give you a moment to take a look at that and get it down. And then about 20 or 30 seconds, we'll go through this together as a class.
What are we going to do?
What is on the screen? So my purpose in this is to show you that there's a pattern that will allow us to construct another index law that's going to make our life easier. I'll give you 10 more seconds. Okay, just copy the line and leave some space. All right, if you're still going, just feel free to stop. I can upload this to Teams straight away, so you can look at it later, okay? All right, let's take a look at this first example here. So here, in this box, I've got 7 to the power of 5 written inside brackets. And then I've got a little 2 outside the brackets. So based on your work on 2a and 2b, you should understand that I take whatever is in the brackets and I square it. So see how I've circled 7 to the 5? I've repeated it 2 times because I've got a power of 2. Here, I've got 7 to the 5, and I've repeated it 3 times because the power outside the bracket there is 3. So let's apply the index law, the one that we already know, this one here. What should we get? 7 to the 10. And what's the in-between step? Shannon?
7, 5 plus 5.
7 to the 5 plus 5. Okay. What about the next one? Stuart?
You do 7 to the power of 5 plus 5 plus 5.
Is this all right, year 9s? See, I'm multiplying the numbers together. This time I've got 3 numbers. I'm still going to do the same thing. I'm going to add the indices together. The only difference between this and this is I'm kind of applying this index law twice because I've got 2 multiplication signs here. All right, and then 3 5s gives you 15. All right, what do you think the next one's going to be? You see where this is going? All right, Damon, you gave me a nod, so what do you think?
7 7 to the power of 5 plus 5 plus 5.
Okay, so we actually did this law last year. I'm wondering whether I have to write the first line. Is there a quicker way that I can do this, Louis?
You multiply the indices.
Multiply the indices, that's it. Okay, so that's today's law, this one here. So notice I've got a number with an index, a to the power of n, written inside brackets, and then I take the whole thing and I raise that to another power. So yes, you multiply the indices. Now, when you read literature, including your textbook, you won't see it written like this. Think back to your study of algebra last year. If I multiply two letters together, m and n, how do we usually write that?
Mn.
Yeah. So when you have two letters together, multiplication is implied. Okay. So even though this looks like two letters here, there's actually a multiplication sign sort of hidden there. It's just that maths people don't want to write so many times signs, and so this sort of saves some time. Okay? But it's important for you to know before you do this next part that when you write two letters together like this, that you're actually multiplying the two letters together. Otherwise, this won't make any sense. Okay? So if you've got two letters, you're multiplying them together, then you write them side by side like this. All right, so let's just quickly do a few examples, and then I'll let you practice on some exercises, and then I'll do one more thing later. Okay, so let's go with Harry. What do you reckon you're going to do with this one, Harry? Any ideas?
2 to the power of 5 times 10.
Mm-hmm. Great. Can I simplify that?
Yeah.
Yep. This part here.
What is that? Just what that is?
Mm-hmm.
50.
That's it. All right, Mitchell, what about this one?
3 to the power of 2 times 7.
Yep. Can we simplify that?
Yes.
Yep.
14.
14. Let's go with Talia. We're having a look at this one now.
Yeah.
What do you think?
15 plus 4 times 6.
Yep. Can you simplify that?
15 and 4.
Thank you. That's great. All right. Do I need to do anything different here?
No.
What's changed here?
Basis.
The base is a letter, but remember, the letter, otherwise known as a variable or a pronumeral, can represent any number. So it's more general, but it's still, just think of it as a number. We'll still apply the index law. So we're just going to multiply the indices together, 9 and 7. And that is 63. Yes, Shannon?
So with these questions, it doesn't want you to find out what the base would be, it would just want you to find out what the actual index would be.
Yes, so what we're doing here is called simplifying. So here I've got two indices, and most people would consider this one here to be simpler because there's only one index here. You asked a good question, Shannon. Do I need to find out what the base is? Because normally you want to solve for x, right, in the equation, but there's actually no equation here. There's not enough information to determine what x is. But if I wrote an equation like this, now there is a solution to this equation. And if you've been doing the extension level questions, you'll probably recognize that the solution to this is actually 3, because 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8. But what I had just now, Shannon, was just something like that. There's nothing on the right hand side, which means there's nothing to solve for. But that's a really good question. Okay.
Can I just ask,
Yes.
when they're seeing a question in their book, if it says simplify,
Yes.
it's very different to when it says solve
Correct.
for. So you've got to read your question carefully, and if it's just asking you to simplify, that's different to when it asks you to solve.
Yeah, that's a really good point. So simplify, your answer will still involve x. When you solve, you will find a specific value for x. So your answer will be a number at that point.
And I'll give you that clue.
All right. How you feeling? Is this okay? All right. I'll just give you one more formula. If you take any number to the power of 0, the answer is 1. I could talk about it now, but it'll take about 10 minutes. I'd rather you just get started on some work. So we'll discuss this at the beginning of period 2. All right, you can now start working on exercise 2C. If you haven't finished 2B, just skip it, leave some room, and start on 2C today, please. All right, thank you.